So let's start our discussion on organic reaction intermediates with carbocation. So carbocation is defined as an organic cation in which the positive charge is located on a carbon atom. Carbocation can be classified into primary carbocation, secondary carbocation, or tertiary carbocation depending on the number of carbon atoms or alkyl groups that are directly attached to the carbon which bear the positive charge. So let's take a look at the description and example of this, which may assist you on how to classify carbocation. We start with the first example. In the first example, we have one carbon atom or one alkyl group that is directly attached to the carbocation. So this carbocation is classified as primary carbocation. In the second example, we have two carbon atoms or two alkyl groups that are directly attached to the carbocation. So the second carbocation is classified as secondary carbocation. And as for the last example, we have three carbon atoms or three alkyl groups that are directly attached to the carbocation. So the last carbocation is classified as tertiary carbocation. So let's watch this video to understand more on carbocation. Now let's proceed to the second intermediate, which is carbanion. Carbanion is defined as an organic anion in which the negative charge is located on a carbon atom. It can be classified into primary, secondary, or tertiary carbanion depending on the number of carbon atoms or alkyl groups directly bonded to the negatively charged carbon atom. So if we take a look at the first example, this is the carbanion. So there is one carbon or one alkyl group that is directly attached to the carbanion. So the first carbanion is classified as primary carbanion. The second example, we have two carbon atoms or two alkyl groups that are directly attached to the carbanion. Therefore, the second carbanion is classified as secondary carbanion. And for the last example, we have three carbon atoms or three alkyl groups directly attached to the carbanion. Therefore, the last carbanion is classified as tertiary carbanion. Watch this video for more information. And the last organic reaction intermediate is free radical. Free radical can be classified into methyl free radical, primary, secondary, or tertiary free radical. Classification of free radical is also depending on the number of carbon atoms or alkyl groups directly bonded to carbon with unpaired electron. If we look at the first example, there is no carbon or alkyl group directly attached to carbon with unpaired electron. So this free radical is known as methyl free radical. For the second example, we have one carbon atom or one alkyl group directly bonded to carbon with unpaired electron. The second example, the second free radical is classified as primary free radical. The next example, we have two carbon atoms or two alkyl groups directly bonded to carbon with unpaired electron. So this free radical is classified as secondary free radical. And last but not least, we have another example that have three alkyl groups or three carbon atoms directly bonded to carbon with unpaired electron. The last example is classified as tertiary free radical. Let's watch this video to understand more on free radical. Now, we are going to compare the stabilities of primary, secondary, and tertiary free radicals, carbocations, and carbanions. For free radicals, the stability of free radicals increases as number of alkyl group increases, meaning that as the number of alkyl group present in the free radicals increases, it will increase the stability of the free radicals. If we compare the stability between primary free radical, secondary free radical, and tertiary free radical, the relative stability is in this direction. Stability increases from primary to secondary to tertiary free radical. As for carbocation, the stability of the carbocations increases as number of alkyl group increases, meaning that as number of alkyl groups present increases, the stability of the carbocations increases. If we compare the relative stabilities between primary, secondary, and tertiary carbocation, it will be in this direction. Last but not least, we have carbanions. The stability of carbanions will be the opposite of the stability of the carbocations. For carbanions, as number of alkyl group increases, it will decrease the stability of the carbanions. The greater the number of alkyl group, the lower the stability of the carbanions. For primary carbanion, secondary, and tertiary carbanion, the relative stability is in this direction.